It may come as a surprise that SD-WAN does not have to be difficult. Building a lab for SD-WAN can be extremely simple. In fact, it doesn't require an organizational name that is registered. It doesn't require a CCO account. It doesn't require you to have SmartNet. It doesn't require you to have a VIPTELA license file. All of these things are true. And if you give me about 90 minutes, I'm going to show you guys how to build a functional home lab inside of an emulator. Specifically, I'm going to use Eve, but you could use CML too. And again, if you give me your attention for about 90 minutes, I'll walk you through the process. And I'm going to start right now. Our first step in building this lab environment and testing out our theories is going to be to take a look at the internet router. Now, the internet router has a series of IP addresses assigned to it. So show IP interface brief, exclude assign addresses. And we can see that I have an IP address being the first usable out of every one of the /30 networks assigned to their corresponding interfaces. I also have a DHCP address assigned to gigabit Ethernet 10. First of all, let's do a ping.8.8.8 to see if we can get to the outside world, and let's do a show IP NAT translations. And we are not doing any natted translations here, but I can get to the outside world as far as those configurations go. And if I do a show run interface gigabit Ethernet 10, we should see that that's configured as an IP NAT outside. All of my other interfaces are going to be inside. And if I do a show run type include IP NAT, we should see that we have an IP and NAT inside source that is overloaded on gigabit Ethernet 10. Now, our first point of interaction in this lab, recognizing what the internet router is configured to support, is going to be to connect to our Vmanage, aka our SD-WAN manager. And our first login to this device is going to use the default password of admin. And it's going to ask us to give it a new password. And I'm going to use 1234, capital QW, lowercase er. Repeat that password. And then it's going to ask me to assign the persona. I'm going to go ahead and say pick compute and data. If you want to understand more about the personas and the explanations of all of these theoretical components, I suggest you take a look at the free course over on sdgeeks.com. I'll have that link in the description. I'm going to go ahead and confirm that persona, and then I'm going to begin the format of the 300 gig drive that's going to maintain all of our runtime data as well as our database information. We'll need to wait for this to finish, and then as soon as this finishes, we will wait for the device to reload, and then we'll access it once again. And then what we need to do is we need to take a look at how we're going to secure certificates. In SD-WAN, certificates are how we are going to end up bringing up tunnels, whether those are going to be datagram transport layer security tunnels or transport layer security tunnels for the purposes of the control plane resources or IPsec or GRE tunnels. Their successful turn-up is going to be associated to the use of certificates that we need to make certain that we get signed. Now, in a lab like this, I'm trying to demonstrate that there is zero requirement for any connectivity to Cisco in order to bring up our environment, meaning we don't need a CCO, we don't need a SmartNet account, we don't need a license file. All we need are the images and a little bit of understanding as it relates to how SD-WAN controller architecture works and functions. So the next part of this is going to require us to get those certificates generated and to sign those certificates in such a way that we can use them. Now, this is going to mean that we're going to need to have a way of being able to generate a key and creating a root CA, because we want to change our authentication model and authorization model over from Cisco, which requires connectivity to PNP, to an enterprise certificate server. So we want to wait for this process to complete. And then what we're going to do is we're going to generate that certificate, and then we're going to use that certificate to configure the graphical user environment All right, the system says it's ready, so let's log into it. So we'll say admin 1234 QWR. And if all goes well, we should access the CLI. Now, what I want to do is I want to do the basic configuration on this device to allow it to do its job. So I'm going to go ahead and type config, and we need to provide the system data. The system data is going to be comprised of a unique host name. I'm going to go ahead and just call it manager, a site ID. In my case, all of my controllers, the validator and the vbond and the validator, the vsmart, and the manager are all going to be in site 255. I'm going to use an organizational name of labfun. This organizational name is just what I'm calling it. It's not set up inside of the Cisco Plug and Play portal, nor does it have to be. The next thing I'm going to go ahead and do is I'm going to identify the identity of the vbond. So in this case, I'm going to probably end up having to wait for this thing to stabilize a little bit more. Probably should have just waited a little bit longer. I think it's finally given up the ghost. So if I do a validation, so do show run system, I should have got the system IP. I want to make sure the system IP is correct. Yes. All right, so let's go ahead and do the rest of the configuration. So my site ID is 255. My organizational name is going to end up being labfun, which again does not exist anywhere in the environment. We are going to, by that I mean it's not registered with Cisco. We need to identify the vbond of 39.1.1. In my case, it's going to be 6. And let's see, we have system IP. We need to have the host name, host dash name, and we said we were going to call it manager. Let's commit this and see if I got everything. So do show run system. So I have the host name, I have the site IP, I've got the site ID, I have the organizational name, and I have the vbond. So that's all I need under system. So the next thing I need to do is enter VPN 0. I'm going to go ahead and do IP route. We'll put a static default route in here for 39.1.1.1. The next hop, we'll go to interface, Ethernet 0 IP address will be 39.112/30. I'm going to go ahead and enable my tunnel Actually, I'll do no shut first. No shut. Tunnel interface. Allow services all. I'm going to go to VPN 512. I'm going to do an IP route for default route here, pointing to 10.1.255.1, which is the router on the host network. I'm going to go ahead and say interface Ethernet 1 IP address will be 10.1.255.199/24 in this case. No shut, and we'll say commit and quit. Now, as a result of this configuration, we've changed the name. Let's see, can I get to the Google server? Yes, I can. As far as that goes, the next thing that I want to do is I need to recognize the fact that we are going to be mounting services. So I'm going to do request network management services all status. And what I'm going to find here is that there are going to end up being a number of services that are in the process of coming up or have been operating for some time. The one that I'm really concerned with is going to end up being this one right here, application server. So the application server, as a general rule, it needs to be up and running for about 600 or so seconds, sometimes closer to 9, before I can really do anything with it. Now, the next step, rather than wasting time, is going to be the fact that we are going to need to modify the default behaviors of the Vmanage. The Vmanage by default is going to be configured to communicate to Cisco for the purposes of getting the certificates for our controllers signed. The default operation will be for WAN Edge devices like CEdge 11 and CEdge 1 in our lab to be signed by the Vmanage. We're going to leave that alone. But the drawback is that I don't want to engage Cisco. I want to demonstrate the fact that You don't need a CCO. You don't need a SmartNet. You don't need a license file. All you need is an organization and a little bit of understanding with regard to how to set up our controllers. And that's what our primary focus is on right now. But to do that, we're going to utilize our own root certificate mechanism. Now, as such, that means I'm going to need to create a key and a root certificate to use. Now, I'm going to call my key SDWAN.key, and I'm going to call my certificate that I'm going to use for my root certificate the SDWAN.pem. Now, you could call it whatever you want as far as .pem, .crt, whatever you want to call it. But at the end of the day, those are going to be the two files that I need to create. Now, rather than installing an instance of Linux or signing on an iOS XE device like I did in the free class, what I'm going to do is I'm just going to use vshell to create the key and to create the root certificate. And to do that from the Vmanage, I'm going to go ahead and go into vshell. Now, from here, you're going to see ls. The only file that I have is going to be the archive_id_rsa.pub file, and that's useless for us right now with regard to what we're trying to do. I want to create a key that I'm going to use to create a root certificate. Now, that key is going to be created using this syntax right here. I'm going to use OPENSSL. I'm going to generate an RSA key. I'm going to call that key SD-WAN.key, and it's going to have a modulus of 2048. So I'm going to go ahead and copy this, and I'm going to paste it into the vshell. There we go. So now if I do an ls, we can see that I actually have a key that I just created. Now, the next thing I want to do is I want to create a root certificate using that key. So the next command I'm going to use is going to be, again, an OPENSSL command that's going to reference the key. It's going to create a SHA-256 certificate that's going to end up being valid for 2,000 days, and it's going to end up employing our organizational name. Now, if you changed or used a different organizational name, which is perfectly fine, just make certain that you substitute yours for what I have as labfun, and I'm gonna go ahead and generate a certificate called SDWAN.pem. I'm gonna grab this entire line item. I'm gonna go ahead and copy it, and then I'm gonna paste it into the Vmanage. Now, when I do an ls, I actually have both those components. I have the SD-WAN key and I have the SD-WAN.pem, which is my root certificate. In fact, I'm going to go ahead and cat the SDWAN.pem file because I need to apply this root CA certificate in my Vmanage when my Vmanage becomes accessible. Now, what does that mean? Well, that means I'm going to go ahead and see if I can't open a browser to that address of https 10.1.255.199 and see if I can access the Vmanage from the graphical user perspective. Now, this is telling me that the services are not all mounted, and it may take me upwards to 5 to 8 minutes for this to actually become responsive to give me the opportunity to log in. So what I'm going to do is I'm actually going to wait until such time that the services are mounted and operational. Now, if I wanted to check the status of those, I could go back I could go exit, and I could say request network management service application server status. And again, I'm going to look to see how long the service has been running. Now, it's only been running for about 404 seconds. Again, I don't even normally bother trying to check until it's about 600 or more. At around 900, it's almost a guarantee that the service is going to be live. But again, remember, my goal is to access it because I want to be able to change the default certificate methodology that the Vmanage is going to use to be able to sign certificates. I want to use an enterprise root certificate server, which is actually going to end up being OpenSSL running on my controllers. So we'll wait for this to hit about 600 seconds, and then we'll check it again. Okay, I think we've given this ample time to run, so let's go ahead and double check the status here. So we're at about 727 seconds. So let's go ahead and refresh, and it's going to give me the login. I can tell because it's cycling there. So we'll go ahead and say admin 1234 QWER. So the first thing I want to do before I touch anything else is I'm going to go ahead and skip the logins here. So do not show me this again. We'll skip that. I don't want to worry about my SmartNet account or anything along those lines. I'm going to go ahead and check out both of those. And what we're going to do is we're going to navigate down to administration. Now, from administration, we're going to go to settings. And under settings, we need to go into the system settings. And what we need to do is we need to identify our organizational name. That means it's going to ask me for the password to make those changes. So we'll go ahead and put that in there. So it's going to end up being the 1234 PWER. My organizational name is going to be labfun. We said that. My validator is going to be located at 39.1.1.6. We save that. Then the next thing I'm going to do is I'm going to navigate down to the trust and privacy section. And under trust and privacy, I'm going to find the controller authentication certification authorization. And it's Cisco by default. We're going to make it enterprise root certificate. And I need to apply that root certificate, copy and paste it into that supplied window. So I'm going to go ahead and grab that one more time. Don't know if it's still in there or not as far as copy. We are going to paste. So that's pasted. So now all we're going to do is import and save. Wait for the confirmation message down here that it's been done successfully. Okay, has been successfully, authorization has been edited. So there we go. So now what I'm going to do is I want to go back to monitor and we want to go to overview. And from the monitor overview, don't show me this again. I don't worry about SD routing right now. We can see that I have one manager, but the problem is that manager needs to have its certificate signed. Every once in a while, you'll even see an invalid hit over here that just says that the certificate's not valid. So the first thing I want to do is I need to generate that certificate request. So I'm going to navigate to configuration, to certificates, to controller components, and we see here we have it. And notice the operational status is blank. I'm going to go over to the three dots, select the ellipses, and I'm going to go ahead and say generate a CSR. And in doing so, what will happen if I get back into vShell before I click it, vShell on the manager, we're going to see there's my key, there's my root certificate. I want to sign the certificate request that gets generated. So I'm going to go ahead and say yes. There is the certificate request. I could download it and assign it. But the thing is what's important to note is that the Vmanage actually is going to create it on the device itself. So if I do an ls, there is the Vmanage _ CSR that I need to sign. To sign it, I'm just going to use OPENSSL, and I'm going to change the file that I'm going to sign from vbon to Vmanage _ CSR. I'm going to copy the entire line. I'm going to paste it into the vShell, and then I'm going to cat the resulting file called cat new certificate.crt. I'm going to grab the entire contents, including the begin and end. Make sure you get all of the hyphens. And then what I'm going to do is I'm going to navigate back to the Vmanage and select install the certificate. I'm going to copy the certificate that I just created into the window and say install. And then we should see the device go active. So scheduled. Look at the process. We want it to stop saying in progress and show a green success. There we go. So green check mark and success. So with this, I'm going to go to configuration, to certificates for control components. And we should see that we have a certificate serial number and we have an expiration date. Remember, I set it for 2000 days. And that device is now part of our environment. Now, with that in play, if I go to monitor and overview, we see that we have the one Vmanage. Let's go ahead and add the next device, which is going to end up being the validator. So from the perspective of the validator, I'm going to access this device and I'm going to do the basic configuration for it. So we'll go to the validator. Log in, admin. We'll need to change the password to 1234, QWER. Repeat it. And now we'll do the basic config. We'll start with system. So config. It's going to be system. We'll begin with the system IP. Actually, we'll do the host name first. Host-name is going to be validator. System IP will be 1.1.255.6. The site ID will be 255. The organizational name will be labfun. The identity of the vbond will be 39.1.1.6. I am the vbond, so I'm going to go ahead and type in the local keyword. So we have the host name, the system IP, the site ID, the organizational name, and the vbond. So the next thing we need to do is configure VPN 0. I'll go ahead and do the static default route, pointing to 39.1.1.5. Interface gigabit Ethernet 00. I'll do IP address 39.1.1.6/30. Now, we may encounter a problem here, and that is going to be something that I've run into in newer versions where it doesn't allow me to be able to do the encapsulation. A vbond is basically just a vEdge. And as such, I'm telling it that it's going to end up acting as a vbond, which changes its roles, but a vbond, like a vEdge, is going to require me to specify the encapsulation type, and we're going to be using IPsec. So let's see if that is indeed the case. So I'm going to say tunnel interface. I'm going to go ahead and say encapsulation, and notice it's not letting me apply it. So what I'm going to have to do is I'm going to have to exit, and I'm going to say no tunnel interface. I'm going to go ahead and commit my changes to date. And then once those changes are committed, it will now let me do it. I'll say tunnel interface. I'll say encapsulation, IPsec, allow services all, and let's see, we'll leave the color at default. So I think we have everything that we need. So I'm going to go ahead and say commit and quit. And let's take a look at our basic configs. So as such, I'm going to say show IP route. Let's see if my static default route shows up. I'm not seeing it. I bet I left the interface off. So show interface gigabit 00. And I did. So we'll have to say config VPN 0 interface gigabit Ethernet 00 no jut. We'll do commit and quit now. Show IP route. There we go. Ping 8.8.8.8. Good to go. Ping 39.1.1.2. So that's my Vmanage. So these elements are all golden. So now we want to go to vshell ls, and I don't have my key. I don't have my root CA, and I need to generate a CSR. So the first thing I'm going to do is I'm just going to go ahead and go to the manager, and I'm going to send those files. I'm going to type scp SDWAN-key or .key to admin at 39.1.1.6 yes 1234 QWER. Then I'm going to transfer the PEM file. 234 QWER. And now they both should be there. I'll go to the validator, I'll execute an LS, and there they are. So now I need the root CA. To get the root CA, I need to add the validator as a validator to the environment. To do that, I'm going to navigate to my Vmanage. From my Vmanage, I'm going to go to Configuration. I'm going to go to Devices, Control Components, and I'm going to add a validator. My validator is going to be located at 39.1.1.6. The username is going to be admin. The password is going to be 1234 QWER. And yes, I want to generate a CSR. So I'm going to add that resource to my Vmanage. Looks like it's been added successfully. Let's go to Configuration Certificates. From Certificates, I want to go to Control Components, and we see that we have the validator that has generated the CSR. So let's see if that CSR is present. It should show up as vbond_CSR ls. There it is. Let's go ahead and sign it by changing the name of the file I want to sign to vbond.csr. Copy the entire line. We'll paste it in. Hit enter. We'll cat the new file. We'll copy it. Again, making sure we get begin to end and all the hyphens. We're going to go to install the certificate, and we're going to paste it into the certificate text, and we're going to install. All goes well. The certificate should get applied, and the device should become serviceable. Okay, has been successfully applied. Let's take a look at the certificate. So Configuration, Certificates, Control Components. We can see that the validator has a serial, has an expiration date, has a UUID for record, says it is quote unquote in sync. So if I go to Monitor Overview, I should see one validator and one manager. So the next component we need to add is going to be the last component we're going to add for control, and it's going to be the controller. So again, let's take a look at that. So from the perspective of the controller, I'm going to go ahead and click it. We'll need to log into it. Admin, change its password, 1234 QWER, 1234 QWER. And I need to give it the base config. So we'll do config. We'll start with system. System, we will first start with a host -name of controller. We'll go ahead and say system IP address will be 1.1.255.10. The site ID will be 255. The organizational name will be labfun. The vbond will be located at 39.1.1.6. Exit, we need to create VPN 0. I need a static default route, so I'm going to go ahead and say that that's going to point to 39.1.1.9. Interface, Ethernet 0. IP address will be 39.1.1.10/30. No shut. Tunnel interface, allow services all. And we will say commit and quit. Okay. So show IP route. Let's see if my static default route shows up, which it does. Can I get to ping 39.112? I can. Can I get to the outside world? Ping 8.8.8.8. I can. So let's go ahead and get this added and go to vshell. And what we're going to find is ls, we're missing the key, we're missing the PEM file, and we don't have a CSR yet, but that should come as no surprise. Let's go to Manager and transfer those files over to this device. So we're going to send it to 10, the key first. Yes. 1, 2, 3, 4, QWER. And then we'll send the root CA.pem file. 1, 2, 3, 4, QWER. Let's go back to the controller, repeat the list command. So we see the key and the PEM file now. So let's get the CSR taken care of. We do that by adding the device. So configuration, devices, configuration, devices, control components. We're going to add a controller. That controller is going to be located at 39.1.1.10 using the admin password of 1234 QWER. And yes, I want to go ahead and generate a root CA to facilitate getting it assigned. Let's go to certificates, control components. It says it's generated. Let's see if it's there. So LS should reveal it, and it should be called vsmart_CSR. Let's go ahead and modify the name of the file we want to sign. So it's going to be vsmart.csr. Copy the whole line and paste it into the V shell. Cat the new file. Copy it, inclusive of the important components. Go back to the Vmanage, install a certificate, paste it into the certificate test block, and install. And wait. And it's done. So just to validate, we'll go back to configuration. We're going to go to certificates, control components. I want to see if I have a certificate serial as well as expiration dates for all three of my resources, validator, manager, controller, which I do. And lastly, we're going to go to monitor. We're going to go to overview, and we should see 1, 1, and 1. So the next part of this is going to be very important, and that's going to end up being, how do I get routers, WAN edge devices integrated? Now, typically, I would tell you that you would have had to have gone to Cisco's plug-and-play portal. You would have had to have created a virtual account. In that virtual account, using your CCO, then you would actually end up creating your organizational name, which must be unique among all of the universal or all of the organizational names in the Cisco plug-and-play portal. Then you would have had to have created a Viptela file that you could download, or a record of devices that you can add to your environment. We're not going to do any of that. The promise of this was to be able to illustrate how to build an SD-WAN environment from 0 to SD-WAN without having to have a CCO, a license file, and all of that. And we're going to do that by engaging something called the pay-as-you-go licenses. So I'm going to go to configuration, to devices, and I'm going to go to WAN edges. And what we're going to see here is I have none. Now, if I had that aforementioned WAN list, I could upload it, but I don't. What I'm going to do is I'm going to add the pay-as-you-go WAN edges. And what I'm going to do is I'm going to add 6 of them. And I do want to update the controller, which means that these licenses, these UUIDs, universally unique identifiers that we're going to get, are going to end up being valid the second they get uploaded. So let's go ahead and create those. They're not even really uploaded as much as they're created locally right here and there. And this information is going to be distributed to the 3 controllers, the validator, the controller, and the manager. Now, to use the actual terminology, the manager is going to end up being our management device. The controller is really our controller, and the validator is referred to as an orchestrator. It's got jobs, and if you are interested in those jobs, again, I recommend You take a look at the free class over at SD Geeks, where I give a lot of the theory that I'm not covering here. So right now, with all of this in mind, I go to configuration and I'm going to go to WAN devices or WAN edges. Under devices, we can see now that I have these UUID/chassis numbers. Now, you'll notice they're all C8000K and they're all pay-as-you-go style licenses. Now, don't sweat. You're not going to get a bill for this. These licenses were designed to interact with resources that you spin up in cloud-native service providers like AWS. Now, we are going to run into something that's a little interesting. It's not going to stop anything from working, at least in this version. And remember, I'm using 20.15.1. I do plan on upgrading to 20.15.4 as a video if that's something that you guys are interested in. But the object to understand here is going to be that the QCOW2 images that I'm running inside of Eve are actually bring your own licenses, BYOLs. Now, we are going to receive a message when I try to use these pay-as-you-go licenses on or in relation to the bring your own licenses. There's going to end up being a license mismatch message and notification. It's not going to stop anything from working. It's not going to constantly plague you and become a problem. It's just that a lot of people have issues bringing the devices up and operational initially, and the problem looks like it's related to this mismatch message because it's not working, and they see the mismatch message and they think that that is going to end up being the direct relation. But if you do your configurations correctly, everything is going to operate. In fact, what I'm going to do is I'm going to do the configuration twice. I'm going to bring SDWAN into the environment, and I'm going to use the manual method. And then what I'm going to do is I'm actually going to create something referred to as a Bootstrap file. And then I'm going to move that Bootstrap file to CEdge11, and we're going to onboard it. Now, CEdge1, for me to do the manual configuration, needs to be in controller mode. I've already taken care of that. So I logged in. I did all of the stuff necessary to get the wizard to give me the CLI. And then I ended up typing controller-mode space enabled, press enter. I've let the device reload and come back up because I didn't want to spend all of the time necessary waiting for that C8000V to reload. So what I want to do next is I want to do the necessary configuration to manually onboard CEdge1. Now, I'm not saying that this is the best way. This is a way of being able to onboard a device among many. We've got zero-touch provisioning. We've got one-touch provisioning. We've got the manual method. We have the bootstrap method. I'm going to illustrate or demonstrate two of those methods here to just simply demonstrate to everyone that they will work as expected. So the first method is going to be to onboard CEdge1 in my environment. So taking a look at my topology, I want to go and take a look at CEdge1. And like I said, CEdge1 is currently operating. I'm going to go admin 1234 QWER as far as the password and admin. So it's set for the default. So I just brought it up. So at this point, I need to give it a new password. So I'm going to go ahead and say 1234 QWER, 1234 QWER. And if I got both passwords to match, it should give me access to the console. So first thing I'm going to do is show version, pipe include mode. We can see if I'm patient or fast enough, it is in controller mode. Now, what you're seeing here is an issue that's associated with the fact that my device, it doesn't have a valid UUID assigned to it. So, like I said, I'm just trying to get it to stay on screen long enough for me to point to. So there it is. So enabling reason reload, enabling controller mode, and it is currently in controller mode. Now, what that means is it is now ready for the Vmanage to control it, since that's the whole objective here. So what I'm going to do is I'm going to go ahead and say config T, and we're going to notice the first thing, and that is that since this box is in controller mode, config transaction is going to end up being the command that I need to use. I'm going to go ahead and just type config-T instead of config T, and that's going to put me into the global configuration mode on this device. So the first thing I'm going to do is give it a host name. I'm going to say host name, just like I would with any other device. This is going to be CAdge1. And I'm also going to give it a static default route that's going to point to 39.1 dot. And in this case, it's going to be 13. So we can see here 12. It's going to be 12/30, 13 first usable, and the next one is going to end up being 14. So in this case, it's going to have an IP address of 13. Then what I'm going to do is I'm going to go to interface gigabit Ethernet, and this is very, very case sensitive, so you need to be mindful of that. I'm going to go to gigabit Ethernet 1, and what I'm going to do is I'm going to say IP address 39.1.1.14, 255.255.255.252, and I'm going to no-shut that interface, and now I'm going to exit. So the first thing I want to do is note that, remember, this is an iOS XE enabled device, but it's running in controller mode, which means none of the configurations are going to take effect until I type commit. So all I want to do right now is I want to type commit, see if those configurations will change. And now what I'm going to do is I'm going to say do. Let's go ahead and say, I'll say exit, and then I'll say ping. Ping 8.8.8.8. Let's see if I can get to the outside world. Can I ping 39.1.1.2? That's the Vmanage. Can I hit 6? That's the Vbond. Can I hit 10? That's the controller. So yes, I've got all the reachability in the world. But now what I need to do is I need to get the configuration in here to support SD-WAN, which is something completely different than what most of us are accustomed to. So I'm going to again go to config-t. And I need to provide the system configurations, just like I did for the Viptela devices. So in this instance, I'm going to go ahead and say my system IP address is going to be 1.1. This is going to be CAdge1 up here is going to be in site 100. And this is obviously going to end up being, well, I'm going to use .1, .2, .11, and whatever as far as the last IP address to make sure reference to the router number. So this is going to be CAdge1 located in site 100. Down here, it'll be CAdge11 located in site 1. So it'll be 11111. So let's go ahead and do that. My site ID is going to end up being 100. My organizational name is going to be labfun. And my Vbond is going to be located at 39.1.1.6. All right, so I'm going to now exit. Now, the next thing I need to do is I need to configure a tunnel interface. And that tunnel interface is actually going to make reference to gigabit Ethernet 1 as being the source of the IP address that I'm going to use for it. In other words, IPN numbered. Now, that's going to look like this. I'm going to go ahead and say interface tunnel. I'm going to go ahead and call it 1 because I'm going to tie it to gigabit Ethernet 1. And what I'm going to do is I'm going to say IP unnumbered gigabit Ethernet 1. Again, no space between gigabit Ethernet and 1, and the G and the E must be capitalized. I'm going to go ahead and say my tunnel source is going to be gigabit Ethernet 1. And my tunnel mode is going to use a tunnel mode that many of us are probably not familiar with. My tunnel mode can end up being UDP, it could be GRE, it can be VXLAN, but in this case, it's SD-WAN, so this tunnel mode is going to be SD-WAN. Now, before it will let me apply this configuration, I need to configure that interface, gigabit Ethernet 1, in the SD-WAN parser. So right now, if I say commit, it's not going to work. Why? Because it's going to tell me, it says, oh, well, gigabit 1 has been configured to be an SD-WAN style connection, but you haven't done any configuration for SD-WAN. So to do that, I'm going to type exit SD-WAN. Now I'm in the SD-WAN parser. I'm going to type interface gigabit Ethernet 1, no space. I'm going to go ahead and say tunnel interface. I'm going to say encapsulation IPsec. I'm going to go ahead and say allow services all because I may need them. And then the next thing I'm going to do is I'm going to specify a color of public internet. Now, everywhere else I've used default for my color on my controllers, but this is a data interface. And since data is going to be moving through it, I want to be able to represent the different transports. Now, right now in this lab, I only have one transport, public internet. But as you can see, if I move my CRT session over here, we can see that I do have the capacity of onboarding another transport that I'm calling MPLS. And we'll probably want to run a routing protocol with it. I'm trying to move this stupid thing over again. And 1 second. All right, so just one more. There we go. All right. So public internet. All right. So I'm going to go ahead and say exit, get out of the tunnel config. I'm going to say no shut. Not that actually, it's not a supported command here. So commit. Let's go ahead and get these things applied. And sure enough, end. What we're going to see here is this device is going to try to onboard itself. You can notice it's trying. So system IP address 11101. The old organizational name was blank. The new organizational name is labfun. But the problem, again, like every other device, is the fact that these are virtual components. So if I say show SD-WAN control and I say local properties, what we're going to find here is this device is trying to connect to our Vmanage using a unique, it's randomly generated chassis ID, but it's not one of the chassis IDs that we created when we use the pay-as-you-go licensing structure. So that's something that we're going to ultimately end up having to modify or change. So from the perspective of this, it's important to note that I need to do a couple of things. So first of all, if I look right here, I'm scrolling up and I look at my organizational name, we've got labfun, and it tells me that my root CA chain is installed. But what it doesn't tell me is that is going to end up being the old school Viptela root certificate. It's not the root CA that I created, SDWAN.pem. So the first thing I want to do is I want to install SDWAN.pem on Edge 1 so that I have the correct root CA for when I try to add this device to my environment. So to do that, what I'm going to end up doing is I'm going to execute a long command. It's going to be request platform software SDWAN root-cert-chain install. Oh, actually, I need to move the file first. So my bad. So the first thing I need to do is I'm going to do a copy SCP to boot flash, and I'm actually going to put this in a directory called SD-WAN. So the IP address is going to end up being 39.1.1.2. That's my Vmanage. The username is admin. The file I want to use is going to end up being SDWAN.pem, and I want to go ahead and put it in that folder that I specified. So a successful password of 1234, capital QW, lowercase r, should result in that file moving. If I look at the dir of boot flash and I look at SD-WAN, what we should see here is there is that PEM file. So what I'm going to do now is I'm going to install the PEM file. I'm putting everything in that SD-WAN subfolder. So what I'm going to do now is I'm going to use that long command, that request platform software SD-WAN root cert-chain install boot flash SD-WAN, and it's going to be the SDWAN.pem file, and I'm going to wait for this to get installed. Now, once this root CA has been installed, the WAN Edge device has the root CA, the Vmanage has the root CA. So when I add this device to my inventory, for lack of a better word, inside of the Vmanage, this device will actually be able to successfully negotiate the formation of control plane tunnels. So I'm going to end up getting DTLS tunnels to my Vmanage, my Vbonds, and my Vsmart. Right now, if I say show SD-WAN and I say control connections, plural, what we're going to find here is that there are none. The reason there are none is that the device is trying to join the fabric, but it doesn't have the right UUID. Remember, we created an entire series of UUIDs. Now, we also through the creation of these, we also created a token, which is not visible. I need both pieces of information. So I'm going to go to the table settings, and what I'm going to do is I'm going to find the serial token, and I'm going to turn that on. And what we'll see here is that it's going to give me a listing of the serial number, UUID, and the token that I'm going to use. So when I tell a device to use this UUID and this token, that's basically saying that device should be allowed to join the fabric. So that's what I'm going to take care of right now. So I'm going to double click on this and I'm going to copy it. And I need to apply that to CEdge1. Again, I need to make CEdge1 match my chassis numbers, not the chassis number that was randomly generated when I created the virtual machine. So in this instance, I'm going to again use request, platform, software, SD-WAN, Vedge, the underscore cloud, activate chassis, and I'm going to paste in that chassis number. I'm going to hit space. I'm going to type token, and then what I'm going to do is I'm going to grab the correct token, and I'm going to apply that. So I'm going to copy, go back to CEdge1, and I'm going to paste it in, and I'm going to hit. And now it's just an issue of waiting. If all goes well, this device should successfully onboard. Now, it is to be expected that we are going to see an error message or a notification message that is going to talk about the mismatch, the license mismatch that I was describing earlier. So I'm going to expand this, see if I can't capture more of it. And we are going to wait until such time that this device that is trying to connect is going to end up being allowed to connect. We'll notice here that say mismatch. We are using a BOL license. It's associated to a pay-as-you-go license. The license type is BYOL. That's the license type of this virtual image. But again, this error message should not result in any type of failure. We should still be able to form a successful set of DTLS tunnels, and when the time comes, we'll be able to form IPsec tunnels between CEdge1 and CEdge11. So when we see that we have formed peering relationships with one vSmart, we know we're good. Okay, notice here it says number of vSmarts connected, 1. Now let's see if it stays up. It's not uncommon for it to drop and then come back up. I'm going to go ahead and enter, take a look at what's going on here. So I'm going to go ahead and say show SD-WAN control connections now, plural. We should see a connection to the vBond, the Vmanage, and the vSmart. Let's take a look at show SD-WAN OMP peers, and we should have a single peering to a single vSmart, our only vSmart. And as a direct result of that, that means that this device is now accessible and should be in the state of managed by the SD-WAN. So if all goes well, we should have a single site that is up and reachable. Now, the site health is going to change over time as far as things go, especially right now since I only have one site. I have a single site, which is site CE1. Now, what I'm going to do right now is I'm going to need to make certain I want CEdge1 to be in a default state. So I'm going to wipe it. And I'm going to need to provide or apply some basic configuration to it. So I'm going to turn it back on. And what I want to do is while it is loading, and again, I want it in autonomous mode. Remember, I said that I had already converted CEdge1 over to the controller mode. I want CEdge11 in autonomous mode because here's what we're going to do. We are going to create a special file. That file is going to be called a Bootstrap file. We're going to call it Cisco SD-WAN _ cloud _ init.cfg. That file is going to contain the root certificate, UUID, the token, and all of the configurational information that needs to be applied to CEdge11 when CEdge11 moves from autonomous mode to controller enabled mode. So what it's going to do is it's going to check its compact flash, aka in the real world, it'd first look for a USB, but this is a virtual machine. So then it's going to check its boot flash, and that boot flash would normally be in compact flash. So as a direct result of that, it'll find that file, looking for that specific file name, and then when it loads into controller mode, it'll apply the configurations inside of that file. Now, that means that we need to first be able to create one. Now, the drawback to this is that we have to have a template. Now, I want to create a device template, and I'm going to create an extremely basic device template while I'm waiting on this device to basically become configurable. And in order to be able to do that, I'm going to create 3 feature templates. I'm going to create a AAA template that's going to say our login is going to end up being admin and 1234 capital QW lowercase er. I'm going to create a second custom feature template that's going to be for VPN 0 that's going to include a static default route that I'll enter via variable, something called device specific config. The third feature template that I'm going to create is going to be a VPN 0 interface template where I'm going to be asked to apply the IP address. I'll go ahead and hard code the tunnel configurations and the allow services and everything. Everything that I did at the CLI in the previous installation for CEdge1, I'm going to do using a template on CE11. So let's take a look and see what that particular ideal looks like. So the first thing I'm going to do is I'm going to go to configuration. I'm going to scroll down to classic, and I'm going to go to templates because, again, remember, we're using the user experience 1.0, and templates work completely different than configuration groups. So under feature templates, all I'm going to do is I'm going to create a new one, and feature templates are going to end up being for specific models of devices, and this one is they're all going to be for C8000Vs. I'm going to scroll down to AAA, and I'm going to create a new one, and I'm going to call it custom AAA template. So we'll say custom AAA template. And I'll copy and paste that into the description. Descriptions are mandatory. So the first thing I'm going to do is I'm going to find the user for admin. There he is. I'm going to edit it, and I'm just going to change the password from admin to 1234 capital QW lowercase er, and I'll repeat that. 1234 QW lowercase er. Save those changes. I'm going to have to go down to the very end and select my group of local. Those are only 2 mandatory as denoted by a red asterisk, and save those. And that's going to give me my first of the 3 templates that I said I was going to create. I guess I more accurately should say first of the 3 feature templates. So the next thing I'm going to end up doing is I'm going to create another C8000V feature template. This time it's going to be for VPN, specifically VPN 0, which is what it will be by default. But I'm going to go ahead and call this my custom VPN 0 template. So we'll wait for it. So this is going to be my custom VPN 0 template. We'll copy that into the description. Copy and then paste it into the description. VPN 0 template. VPN 0 template. So the first thing I want to do is by default, it's going to be VPN 0. Then what I'm going to do is I'm going to navigate all the way down to my IPv4 routes, and I'm going to include a static default route, and I'm going to ask it to provide a variable for the next hop, 0.0.0.0/0, my next hop. I'll add a next hop. I'm going to say I want to use a device-specific configuration, which means I'm going to be making reference to a variable. I don't like that one that they're giving me here. So I'm going to say G1 next hop IP. So Gigabit Ethernet 1's next hop IP address. I'm going to go ahead and say add that. And that should be all I need. Now you can see there's a lot of stuff to select. And again, if you want to learn more about those, go ahead and take a look at the free class over at SD Geeks. So next thing I'm going to do is my interface template for AC 8000V. Scroll down to where I get to VPN interface Ethernet template. And this one will be custom VPN 0 interface template. So we'll say custom. Let's do it this way. We'll say VPN 0 Gigabit Ethernet 1 interface template. We'll copy it and paste it. Because at some point I am going to do a Gigabit Ethernet 2 if you guys are interested in seeing that, or the second transport. So globally, we want to no-shut the interface. The interface in this case is going to always be Gigabit Ethernet 1, so I'm going to go ahead and just hard code that. However, the IP address will need to be statically assigned, and to do that, I'm going to use a device-specific variable. And that device-specific variable is going to be G4 IP mask, just to remind me to put the mask in. Now, the other part of this is going to end up being I am going to want to enable the tunnel. So globally, my tunnel is going to be on. I got a little artifact here that's just driving me bug nuts. Let me double check and make sure that didn't change. So P1 IP mask. Tunnel. I want my tunnel on. My color is going to end up being, let's go ahead and just do it globally instead of defining one. So globally, I'm going to pick public internet. Not going to worry about restrict. I am going to allow services all just to make my life easier. So globally, we'll turn that on. No NAT, no quality of service, no core specs. So fundamentally, what we've got is the three components that I need to make this unique enough. So now what I'm going to do is I'm going to take these individual building blocks and I'm going to navigate to device templates, and I'm going to end up building an object from feature templates for my C edges. So again, the model here is going to be C8000V. Unfortunately, I got to scroll until I find the right one. I always scroll past it because I get impatient. So we're looking for C8000V. There it is. The device role is going to end up being WAN Edge. Service nodes we'll talk about maybe, maybe not. Again, depends on, the levels of interest. I'm going to go ahead and call this all C edges, and I'm just going to say for onboarding. I'll copy and paste that into the description. Paste. So the first thing I'm going to do is scroll down, and I'm going to pick the AAA that I wanted to use. So the one that I made, custom AAA. I'm going to go down to VPN 0. I'm going to pick the VPN custom that I created. And for the interface, I'm going to pick the custom VPN 0 interface that I created. Not going to do anything with VPN 512. I have no service VPNs, nothing. I'm just trying to provide enough information to be able to add a device to the infrastructure. So that means everything necessary to be able to successfully create tunnels, both DTLS, TLS, and or IPsec and GRE. So with this, now what I'm going to do is I'm going to go to the more actions, and what I'm going to do is I'm going to attach a device. Now you'll see in my listing, I have a list of devices. Waiting for this thing to check. So CAdge1 is already occupying one of the 6 pay-as-you-go licenses that I used. I'm going to go ahead and grab this one right here and move it over to the selected column. I'm going to hit attach, and what this is going to do is it's going to ask me to provide the information or the value for all of the variables. So I'm going to put this in a columnar format so I can see everything. So this is going to end up being site 1. My system IP address will be 1.1.1. In this case, it's going to be 11 since it's R11. The host name will be CAdge11. Okay, and now I need my IP addresses. So what is my IP next hop for that device? So for gigabit 1, it's going to be 16. So 17 is going to end up being the gateway of last resort. So it'll be 1117. So in this case, it's going to be 39.1.1.17, which means my IP address is going to be 31.1.18/30. And that should give me all of the information that I need to get this device back and connected to the underlay for the purposes of creating a successfully orchestrated overlay. I'm going to go ahead and configure the device, but bear in mind, this device is not online. So what the Vmanage is going to do is the Vmanage is going to say, okay, we're going to associate all of this information to this specific UUID, this chassis number right here, with whatever the token was for that UUID. And as soon as that device becomes active, we'll apply that running configuration to the device itself. So the object of the exercise here is we're basically waiting for the Vmanage to create all of the relevant running configuration information to include the certificates. So notice it says here, it says configured device all C edges for onboarding scheduled to be attached when the device comes online. To check the sync state, click configuration devices and device options. Now I know the device isn't live because the device is in the process of just coming back on. So let's take a look at CEdge. I just wanted to get off of it. So let's go ahead and take a look at CEdge 11 from the perspective of the board. So yeah, this box is pretty much useless. It's a brick. So the first thing I want to do is I want to go ahead and create that Bootstrap file that we were talking about. So I'm going to go to configuration. I'm going to go to devices, and I'm going to go to WAN edges. And we're going to see that I have 2 devices in my WAN edge list now that actually have templates assigned to them. So CEdge 11 has this template, and notice it says its sync is pending, the device is offline. Now CEdge 1 has configuration in the system, but there is no template associated to it. So notice in this instance, this device is not locked, which means it's not in vmanaged mode. When this device goes live, because it does have a template, it will be locked, which means all subsequent changes and modifications will have to be applied via manipulating the template, and we will ultimately end up being locked out of the CLI. But we're not there yet. I want to get a Bootstrap file, so I'm going to go to the more options. I'm going to go ahead and say generate a Bootstrap configuration. And I do want to go ahead and include the root certificate so I don't have to move anything. And cloud init means it's going to do it to be compatible with iOS XE, which happens to work with CML2 as well as the EvenG engine. So now what I'm going to do is I'm going to go ahead and say OK and generate that Bootstrap file. Now that Bootstrap file is going to include everything that I need. Notice there's the UUID. There is the token. It's called an OTP. There is the identity of the vBond. There is the labfun organizational name. And it says, hey, we're using a trusted certificate. And there's my root CA that is being applied and all of the associated certificates. If I scroll all the way down even further, what I'm going to see is I'm going to actually start seeing configuration commands. So let's go all the way down. There we go. So here's my configuration commands. So we can see, and this is basically in Viptela format, but we can see the BFD, the configurations. We should be able to see the IP addresses. There's Gigabit Ethernet 1. Notice I said that it was going to be public internet as far as the configurations go. And ultimately, this is all the configuration necessary to apply to that device, Edge 11, in order to get it onboarded. So what I'm going to do is I'm going to download it. Now, this is on my desktop. Now, the problem is if you look at the infrastructure from my desktop, I only have one point of connection. I did not create VPN 512 configurations or interfaces for every device. So what I'm going to do is I'm actually going to, from my desktop, I'm going to send that .cfg file to my Vmanage. So I'm going to need to take a look at directory of anything.cfg. And what I want to do is I'm going to SCP that file. So I'm going to say SCP C8K 87C, and then the last four. Yep, that's it. Config. I'm going to go ahead and send that to admin at 10.1.255.199, and I want to put it in the root of admin. And to do that, I'm going to go ahead and say yes and use the password. And then if I jump over to the Vmanage, from the perspective of the Vmanage, if I look at vshell ls, there is my file. Now I need that name. All right, so now what I want to do is, just want to make sure that it was copied. Now what I want to do is I need to go to Edge 11, and I want to install that file, that .cfg file, in my compact flash. So to do that, I'm going to go to Edge 11, and what we're going to find here is I need to go ahead and say, no, I'm not interested in this. I'm going to give it a password of $NXOS12345$, $NXOS12345$. But I'm going to say don't use that password. I just had to have something to satisfy the password complexity. And then what's going to happen is this box is going to end up being in autonomous mode. Remember, the other one I manually converted to controller mode. So I need some things. So I need reachability first. So I'm going to go ahead and say, I'm going to go and say config T, because this is autonomous mode, IP route 000000000 is going to point to 3911, and just as a refresher, that is going to end up being, damn it, 17 as the gateway. So 17 is the gateway. All right, so let me drag this back up. All right, so like I said, it's going to end up being 17. Interface gigabit Ethernet 1 IP address is going to end up being 39.11.18.255.255.255.252. I'm going to no shut this interface. I'm going to say end, and I'm going to say ping 39.1.1.2, the IP address of the Vmanage. So what I want to do now is I'm actually going to copy SCP to boot flash. Okay. The IP address is going to be 39.1.1.2. Admin is the username. The file that I want to copy is going to end up being that big long file that I just created, that guy right there. And now what I'm going to do is I'm going to say, when you save it to the destination, so when I save that locally on my, or in my, my boot drive or my boot flash, I want to call it Cisco SD-WAN _ cloud _ init.cfg, because that's the name of the file that device is going to look at when it converts over to controller mode. So directory, that file is right there. And if I were to more it, so we say more boot flash for Cisco SD-WAN, there is all of the contents to include all of the certificates and the running configuration that will be applied to the device. So all I do now is I say controller mode, enable, hit enter, confirm, and then sit back and let nature take its course. So this device is going to be reloading as a result of a mode change. So reason for the reload, enabling controller mode. So let's sit back and wait it out. So the device has booted into controller mode. So notice it says right here, loading day 0, cloud init bootstrap config. Says it's copying it from that I created. To apply its configuration, the device should come up. Now what we're going to do is we're going to wait for it to form its peering, knowing that it's successfully accomplished what we asked it to when we see the vSmart connections. It's also a fair game to expect to see that license conflict, that mismatch message. But again, it should not stop it from working. There you go, system, license mismatch severity. And notice it recognizes itself, CAdge 11. All daemons are up. So we're waiting for the vSmart resolution. Again, it's not uncommon to see it detach from the Vmanage a couple of times. So up here you can see it, ESG, Vmanage connected. It's not uncommon for that to come down. Of course, this might actually be the second time. Let's scroll up a little bit. So, nope, it's the first time. I'm fully expecting the Vmanage connections to drop. There it goes. To be expected. All right, so we can see here number of vSmarts connected, 1. Peer state. Again, it's not uncommon to see that even drop once. So you can see the vSmart peer handshake, state change to up. Let's take a look at the results. Admin 1234 QWER has the name. Show IP route. See if we've got the static default route, which we do. Show SD-WAN control connections, plural. There we go. Like I said, I was waiting for it to reset. So we got none connected, but now we're reconnected. And again, that's all based on the certificate turn up. All right, so show control connections. We have our vBond, we have our Vmanage, and lastly, we have our vSmart. If I say show SD-WAN OMP peers, we should have one connection to one vSmart because it's the only vSmart. The state is up and operational. And just as a wild check here, let's do a show SD-WAN BFD sessions and see if I have any IPsec tunnels, which I do. I have an IPsec tunnel that goes between my address of 39.1.18 to CAdge 1's address of 39.114. So if I were to log back into the Vmanage and take a look at monitor, we should see that we have 2 WAN Edge devices that are operational, and we can see that our state has gone from from poor to fair. And over time, that's actually going to end up getting better. So with this, what I've tried to do is I've tried to illustrate the simple fact that you don't need all of the moving parts that even I say that you need to build a lab. Now, obviously, I like building larger environments. I like having, more than one vBond, more than one vSmart. I like to talk about resources and applications like controller affinity, as well as OMP route manipulations, long before we ever get into the concept of policies and any of the other more advanced configurations. but I just wanted to take the opportunity to demonstrate that it is entirely possible to build an SD-WAN environment from scratch without having to have a CCO account, a SmartNet account, organizational name that's valid, an associated set of Viptela license files in order to be able to onboard your devices, simply to do something as straightforward as train. So I'm going to go ahead and stop here. If anyone's interested in seeing any more videos in this specific series using this specific technology or this specific topology, I am willing to do other videos. However, in order to be able to make that worthwhile, I need to make certain that you guys at least offer me some type of, comments or things along those lines. So I'll look for any type of requests or any type of questions in the comments. And also, as always, if you're finding this useful, please like and subscribe. So with that, I'm going to go ahead and stop here. Again, I'm Terry Vinson, and I hope this was helpful to everyone. Till then, take care.